page 74, we've got another real typical kind of word problem that that you'll see again, and this has to do with plane speed and wind speed. So you guys have probably noticed that when you fly in an airplane, it's not only how fast the plane goes that affects how long it takes your trip, but you also are affected by the speed of the wind. So if your plane was going in dead still wind, then it would be going at its own rate the whole time. But that very rarely happens. We usually have a wind speed that either slows you down a little bit or helps you speed up, actually gives you some more boost to your rate. So these two factors, the plane speed and the wind speed, are what we're going to use to solve some of these real standard system equations. So again, we're going to set up a chart. Again, this has to do with distance equals rate times time. But now our two different scenarios are the plane traveling against the wind and the plane traveling with the wind. So we're going to let x and y stand for those two speeds because we don't know either one of them in this problem. We do know how far they went, though. He went out 8,400 kilometers and back 8,400 kilometers. So their distances were the same. And it also talks to us a little bit about how long it took to get there and get back. So against the wind, it took 7 hours. Coming back with the wind was pushing you a little bit. The wind pushes you and makes you go faster. It only took 6 hours. And we said that we need to use X and Y over here. Here's how you set up this, how fast they were going. So the plane going by itself is X speed. But when it has the influence of the wind, if you are going against the wind, you have to subtract the wind speed. You are going slower than your normal plane speed would go in dead still air. And conversely, when you have the wind with you, you are being given a little boost. You're going your plane speed plus a little extra. So that's how we set up this part of our chart. And now, of course, our two equations are pretty straightforward. They are distance equals rate times time. So 7 times x minus y is equal to 8,400, and 6 times x plus y is equal to 8,400. So if we go ahead and solve these, or at least divide through by 7 to make this look a little friendlier, divide both sides by 7, we get x minus y is equal to 1,200. And divide both of these by 6, we get x plus y is equal to 1,400. So here's our system of equations. They really are nice, small, little, neat equations. So we could just stack them up. Actually, the y's are going to cancel for us nicely when we use the addition method. So we end up with 2x equaling 2,600 for x equaling 1,300. So that's how fast the plane was going, because that's what we let x stand for. And then if we use the x plus y equal 1,400 equation to go ahead and plug in to find y, subtract 1,300 from both sides, and you get y equals 100. So to answer the question, therefore, our answer is the plane was going 1,300 kilometers per hour. Don't forget your units. And the wind speed was, of course, much slower at 100 kilometers per hour, but still enough to affect the speed of the plane. So once again, we've got one more for you to set up. It's it's exactly similar, so it shouldn't take you very long to set it up, and then we'll talk about it in class. Maybe we'll go ahead and solve them in class. Thanks for watching.